Hello everyone, welcome to the mathematics in my channel. In this video we are going to evaluate this interesting integral from 0 to 1 arcsine of square root of x times arccosine of square root of x over x dx. Okay, what do you think? Let's start with use substitution. Here square root of x, here square root of x, so square root of x is equal to t, then we know x is equal to t square, then we can differentiate dx is equal to 2 times t dt. Now we can substitute to our integral. So we have here now limit we know also 0 to 1 arcsine of square root of x we know t, and cosine of square root of x again we know t over x we know t square dx 2 times t dt. Now we know this t get cancelled and this 2 constant, so we can write outside of the integral sign 2 times integral from 0 to 1 arcsine of t times arccosine of t over t dt. Well, then we know arccosine of t is equal to pi over 2 minus arcsine of t. So using this formula we can write 2 times integral from 0 to 1 arcsine of t over t times arccosine of t we know pi over 2 minus arcsine of t dt. Now we can remove the parentheses by multiplying arcsine of t over t. So here we have 2 times arcsine of t over t times pi over 2. So we know this pi over 2 get cancelled, pi is a constant, so pi times integral from 0 to 1 arcsine of t over t dt, then here 2, so minus 2 times integral from 0 to 1. Now we have arcsine of t, so we know arcsine square of t over t dt. Well, now we have two integrals. To evaluate these integrals I'm going to use a common substitution. So we can take arcsine of t is equal to theta. Arcsine of t is equal to theta, then we know t is equal to sine of theta, then dt is equal to cosine of theta d theta. Okay, now we should change the boundary, upper limit and lower limit. Here pi, now when t approaches to 0 we know sine of here also 0. When t approaches to 1 we know sine of pi over 2 is equal to 1, so here pi over 2, so 0 to pi over 2 arcsine of t theta, so theta over t sine of theta times dt we know cosine of theta d theta, then minus 2 times again here limit 0 to pi over 2 arcsine t we know theta, so theta square over t again sine of theta dt again cosine of theta d theta. Okay, let us simplify a little bit. So here phi 0 to pi over 2 cosine over sine we know cotangent, so theta times cotangent of theta d theta minus 2 times integral from 0 to pi over 2 theta square cotangent of theta d theta. Okay, now we have two integrals and both are same type, product of two functions. So we can apply integration by parts, IBP method, for two integers, both integers. So here pi times integral from 0 to pi over 2. Now as a first function I am going to take theta, then d by d theta. Integration of cotangent of theta, we know natural log of sine of theta d theta minus 2 times integral from 0 to pi over 2 as a first function. Here also theta square d over d theta. Integration of cotangent, we know natural log of sine of theta d theta. Okay, then we know here pi times parentheses, now product of these two functions, so theta times natural log of sine of theta from 0 to pi over 2 minus integral from 0 to pi over 2. Now we need to rewrite second function here, natural log of sine of theta times derivative of first function theta with respect to theta, we know 1. So here d theta, then here minus 2 times we know product of these two functions, so theta square natural log of sine of theta from 0 to pi over 2 minus integral from 0 to pi over 2. Now derivative of this function, so we know 2 times theta natural log of sine of theta d theta. Okay, now we can simplify. We know if we apply pi over 2, sine of pi over 2 1, but natural log of 1 is equal to 0, and if we apply lower limit 0, here 0, so we know this part will be 0, here also 0. So we have here minus pi times minus pi times integral from 0 to pi over 2 natural log of sine of theta d theta. Here minus plus 2 times 2 4, so plus 4 times integral from 0 to pi over 2 theta times natural log of sine of theta d theta. Okay, now here minus pi times, now in a previous video I solved this integral 0 to pi over 2 natural log of sine of theta. So if you want you can watch this video. So I will add the link in the description. Here we know the answer of this integral minus pi over 2 natural log of 2, then here plus 4 times. Here I also solved this integral in a previous video. If you like to watch that video, I will add the link in the description and also make a card. So this is the answer for this integral, minus 5 square over 8 natural log of 2 plus 7 over 16 theta of 3. Okay, then we can simplify. Here minus plus 5 square over 2 natural log of 2. Here we know 4, here 8, so 8 4 we know get cancelled, so 1 over 2, so minus 5 square over 2 natural log of 2, then 4 times 7 over 16 theta of 3, so we have 7 over 4 times theta of 3. Now we know this part get cancelled, so 7 over 4 times theta of 3. This is the answer. If you like this type of videos, please subscribe this channel. Thank you for watching.